Hello everyone, welcome to another video. Our task for today is to exploit a Linux machine on HackTheBox called WifineticTwo. It's a medium difficulty machine. Let's read some information about the machine. So WifineticTwo is a medium difficulty Linux machine that features OpenPLC running on port 8080, vulnerable to RCE through manual exploitation of CVE 2021-31630. Alright, so you can read more about this CVE on the National Vulnerability Database. So after obtaining an initial foothold on the machine, a WPS attack is performed to acquire the Wi-Fi password for an access point. Alright, this access allows the attacker to target the router running OpenWRT and gain a root shell via its web interface. Alright, so this is the information about the machine. So try to replicate this on our own and see if we can pawn this machine. Alright, so without much I say, let's go back and see if our IP address is ready. Yes, so this is the target machine IP address. We'll click on it and then it copies it to clipboard. So we try go to our machine and then we'll start scanning the machine for open ports and services. Alright, so we'll do sudo nmap tac scv tac on. Alright, so we want to save our nmap output into a file called nmap. Alright, and then we want to see verbose output, and then let's use t4. Alright, and that should be all. That should be it. So I'll just slap the IP address here and then the scan should take place. Alright, so let's call this one map2. Alright, so the scan is taking place. This can take some time, so because of that I have already done the scan. I'll just show you the results of the scan. So I'll open the nmap results from Sublime or with Sublime. So nmap, and then so this is the result. So we have two ports coming back. So we have port 22 SSH or OpenSSH version 8.2. Alright, and then we also have port 8080, which is an HTTP proxy running on a WebSocket server, a Python server. Alright, so so let's see if we can access this proxy server. So let's go there. Let's see. So we do HTTP and 10.10.11.7 and then port 8080. Alright. Okay, very well. So we are greeted with an interface, a login interface, asking us for credentials. So this is welcome to OpenPLC. So PLC is a programmable logic controller. Alright, so OpenPLC is an open source project that allows you to be able to interact with this PLCs via a runtime and then an editor. Alright, so that's just a bit of information. So we have the interface here, but it needs us to log in. We don't have the login credentials. We can try to brute force this login page, or we can also search for default credentials. Let's see. I'll say OpenPLC default creds. Let's search for this. Reject everything. Alright, so here we see that the default username and password for web interface is OpenPLC and then OpenPLC. So we use OpenPLC for both username and password. So we say OpenPLC, and then we copy the same and then we paste it for password and see if this will allow us in. Alright, so so we got logged in. We have access to the OpenPLC web interface. Alright, so what we'll do is we can search for exploit for this particular OpenPLC if there are any exploits. So look for OpenPLC exploits. I think I saw exploits. Okay, so we have exploit here, and then we can see that we have some exploit and proof of concepts. Alright, and then the exploit, we have a CVE 2021-31630. We can go to exploit DB. We can look at the exploit DB proof of concept or exploit for that. Alright, let's see what exploit DB says. So this is a remote code execution vulnerability, but we have to be authenticated. So yeah, we can authenticate ourselves because we know the username and then the password, which are the default credentials, so this shouldn't be a problem. But what happens is that this exploit probably will need a lot of modification to let it work with our current instance of the one OpenPLC hosted on HackTheBox. So I tried it didn't work. I didn't want to waste a lot of time, so there's a way we can still exploit this OpenPLC vulnerability manually. All right, so we're going to go the manual way. So what we do is, when you come to this hardware option, it provides it gives you the option to be able to run some C code. Okay, so you can run code here, so to give more functionality to the logic controllers. All right, so here these are the codes that we have. So this is C code. If you're familiar with C programming, you should understand what is going on here. So what we do is, whatever code you put here, if you save the code and start the PLC, it will run that particular code. All right, so what we can do is we just go and search for a reverse shell in C. All right, so that we'll slap that code in that particular box. So I will just look for C reverse shell from GitHub. All right, so the first one that comes, I always go with the first search results. It always works for me. So let's see if this one will work this time. Let's wait. It's taking a bit of some time. Yeah, so we have a Linux version and then the Windows version of the C, but our system is a Linux machine, so we go in for this. So we select the linux.c. so this is the source code. All right, so the source file, linux.c. so we have source file, object file, and all right, so yeah, so what we do is we just copy. We are going to copy this headers to the headers have to come first before any other code. All right, so you paste it here, and then we have some constants are defined here. All right, so client IP, so the client IP, we have to put in our, we are trying to put in a reverse shell, so we have to put in the IP of where we are going to listen from. So we can get that, we say IP address, and then we grep 4x0. We should be able to see the IP. So our IP is supposed to be 10.10.14.79. all right, not here. Okay, so we'll go back to that particular web interface. So that's our reverse shell. We'll be receiving our reverse shell on this IP, and then the ports, you would like to go for port 888. all right, so yeah, so that's it. And then we have some functions here which they've not actually populated the function with anything, so we can make use of that. So this is edit custom layer, so this initializes the custom layer. And then let's see if we can put our reverse shell in this part of the code. So this is our reverse shell, so this is the main function, but we don't know whether there are other main functions elsewhere in this code. Maybe we may have some other files that will all be brought in to compile, so we are not going to add the main portion of our code. We just go here, let's open it in raw, let's view it in raw format. All right, so we start copying from this side to the exec CVE side. All right, we don't add the return 0 because we are not copying the main. So if you add a return 0, so the main function is waiting for a return value, but since we are not copying the main, we are not adding the main function, we leave the return. All right, so we are also leaving the return. When you check this function, it's void. Okay, so it's not returning anything, so you don't have to add a return 0. Okay, that's fantastic. So if everything goes on well, this should be able to compile. So when you click save, it should compile it. Let's see if this works. Okay, yeah, so compilation finished successfully, so it's been able to compile it. But okay, so we'll go back to dashboard, and then we can start our PLC. So when we start the PLC, it will run the code in the hardware where we modified the code. All right, but before we run that code, let's try to set up a listener. So rl wrap and say lvmp, and then we choose port 888. That was what we put in the code. So we are going to listen on port 888. So we go back here, and then we start our PLC. So if everything goes on well, we should get a reverse shell. Yeah, so we can see some connection here has come back. So if we do ID, so we are root. All right, so let's try to get a proper shell from here. So we use scripts, if null, and then C, and we're gonna use bash. All right, so this one gives us a proper prompt. All right, so we cannot clear our screen at this stage, so we need to set our environment variable for term. So we say export term equals to xterm. All right, so now we can now clear. Okay, and then we can cd to home. All right, I always want to cd to home and look okay. So home, we don't really have much here, and that should be it. All right, so I want to find our user flag. So find, and then what do we do? So name is user.txt, and then type is a file, and then ls to dev null. All right, I'm just trying to search the location of our user flag. All right, so our user flag is stored in at root/user. So we can cut our user flag. We can check the content of our user flag. All right, so we have our user flag. Good, so we have one flag. So the next thing is to look for our root flag. So here, so I'll just come back here. Let's try to take some notes. So I'll use Sublime, and then WifineticTwo note.txt. all right, so this is where I want to save my notes. So let's bring it back here, and then I'll say flags user roots. All right, so the first flag we have is the user flag. Okay, and then we go forward. So we are now gonna hunt for our root flag. All right, we have a long way to go, so let's continue. Okay, so let's clear our screen, and then what do? We can just try to enumerate the box pop around, but we are not going to waste much time. We're going to go straight forward through the steps. So if we do ifconfig, here we can see that we have a wireless interface. All right, wireline 0. Okay, so since we have a wireless interface, we can try to scan for wireless access points. Okay, because we have a wireless adapter in the machine, so try to scan for wireless interfaces. So the wireless access point. So we use IW and then WLAN 0, and then if you say scan, all right, so it's gonna scan for access points that we can connect to if we have the right credentials. All right, so here it's been able to find something. Okay, so we have an access point with an SSID of PLC router. So we can copy this information. Let's do that. Okay, so there's an access point called with SSID PL router. Let's see what is at the top. Okay, so it also has a BSSID. All right, a BSSID can also be termed as like the MAC address of the access point interface. All right, so we have this information, and then what else do we have? So when we look down, all right, so we can also see that it has WPS. all right, so Wi-Fi protected setup is configured. Okay, so WPS is not very secure, so if it has this WPS setup, we can try to see if we can brute force the WPS pin. All right, what happened here? All right, if we can brute force the WPS pin. Okay, so let's try that. Let's try that. So what we can do is we can use one shot is a tool we can use to brute force WPS pins. So if you don't know about it, we can just do a search WPS brute force GitHub. So we are looking for tools to brute force WPS from GitHub. All right, so let's see what we have here. So the first one, so yeah, so this is what we are looking for. We are looking for the WPS, we are looking for the one-shot WPS tool. All right, so this one can do a pixie dust brute force attack. All right, so we just go here and grab it. Okay, so how to use it is here. We have information on how to actually use this. But first of all, let's clone this repo. All right, so we clone the repository onto our local machine because our remote machine doesn't have internet. Okay, so let's clear this and we do git clone the repo. Okay, so if we ls, so we have one shot, so we can do ls minus l one shot. So we see the files in one shot. So one shot, we have one shot .py and then we have pins.csv. So we have to send these two files to our remote machine, which we have the foothold on. So what I would do is I'll just copy them, one shot.py and then one shot pins.csv. I'll copy them into the current directory. Clear. When I list, you can see we have them here. All right, so what I would do again is to host an HTTP server, a Python HTTP server, so that we can transfer the files onto the remote machine. So what I will do is I'll just use Python 3 m http.server. All right, so that's it, and then we can come here. If we ls, we have this Ubuntu. Let's see if we can write in this folder. Yeah, we are root already, so we should be able to write into any folder because we are root. So we just use curl http and then 10.10.14.79 and then 8000. All right, so it's hosting the files on this particular port, and then we say one shot.py, and then the output is going to be called one shot.py. all right, okay, so it's copying this. I think it has been able to copy. So we do again, but now instead of one shot, we want to copy the pins.csv, and then we save it as pins.csv. all right, so that's also copied. We can list and see. So yeah, we have one shot and then pins. All right, so what we're gonna do is to use this one shot to scan the to try to brute force the, how do you call it, the WPS key or pin. All right, so it's simple. We just do Python tray and then we specify one shot.py. all right, and then we specify an interface which is going to be WLAN 0, and then we want to do a pixie dust scan brute for a pixie dust attack, which is I think tag K, and then tag B is for brute force. If we can confirm this from the all right, so I is the interface, and then pixie dust, so that's the pixie dust tag A K, and then tag B is the brute force. All right, so we are right, we are on the right track. So if everything is right, it should be trying to brute force our access point, the WPS pin for the access point. So let's see. So something is happening. It's running WPA supplicant. Okay, so it's asking us to make a choice. All right, so from the scan, it's been able to determine, it's been able to see an access point. So the SSID is PLC router. So we wanted to confirm it. That's what we want. If there were others, we could have used the numbers to choose whichever access points we want to interact with. All right, so one, we just choose one because it's the only one there. All right, so pin generated for, so it has generated pins for this particular BSSID. So these are the pins, so you can choose whichever pins you want. So you just want to choose empty pin. So if when you select empty pin, which is the option 11, it will just use the default 0 to I think 7 or so. All right, so we choose option 11. Okay, so it's going to start from 1 to 7 to 0. So we're going to use 1 to 7 and then 0. So this is the pin that it's using, and then it's been able to grab our WPS key, our WPA pre-shared key. So this is the PSK. All right, so let's copy this. So we say we've been able to retrieve the key, the pre-shared key for our access point. All right, so now that we have our key, we can use this to associate with the access point. All right, or connect to the access point. All right, so that's what we're going to do next. Okay, so we're trying to associate with the access point, but first of all, yeah, if you try the IW config, you see that we are not associated, so we are in the manage mode. All right, the access point not associated, so the access point is not associated to any access point. All right, so we want to change that. Now that we have credentials, we can connect to that particular access point. All right, so we have to create a WPA supplicant config file. That's where we'll put our credentials, the key, and then the how do you call it, the SSID. All right, so let's do that. So we use cat EOF and a file, and then we're going to call it WPA.conf. all right, and then we say network. So the network is going to be, let's say it's going to be like an object containing the information in it. All right, so the first so we'll first of all specify the SSID. So that's going to be the name value pair. SSID is, we know the SSID to be PLC router. We can confirm that. What is it? Yeah, SSID is PLC router. All right, and then PSK, that is the pre-shared key, is going to be the key over here. So we have our pre-shared key. Okay, so we put our pre-shared key here, and that's fantastic. All right, so that's the end of it, so we can close it. All right, so now if we cut WPA.conf, we should be able to see. All right, so yeah, so it has been able to put our information in the config file correctly. Okay, so we're gonna use this with WPA supplicant to associate with the router or the access point. Okay, so how do we do that? We just use WPA supplicant. I think it's WPA supplicant, and then the interface is WLAN 0. Okay, and then our config file is WPA-conf, but we have to specify tag B so that it will run as a background daemon. Okay, if not, we will not be able to have access to our prompt again. All right, so this tag B is very important. So let's see if that will work. All right, so successfully initialize WPA supplicant. So let's go back and check IW config and see if we are associated. Very good. So now we are associated with this particular access point. Fantastic, great. All right, so now that we are associated, we are part of the wireless network, so we can try to scan and see whether we have other devices, or other PCs associated to that particular Wi-Fi network, or we may even be able to get the IP address of the access point. So that's what we're gonna do. So we use app. So that is going to use address resolution protocol app tag I. So the I, we're gonna do the app on the WLAN 0. If you don't specify the I, it will try to app on all interfaces present. All right, so we want to be specific, so use I WLAN 0, and then yeah, I think that should be it. Let's see. Okay, oh, yeah, so we're trying to do an app on the WLAN 0 interface. So it's saying app to interest match not found. So let's see let's try and see if we have the right syntax for app. Maybe okay, so app. Okay, so let's just do app, and then we'll do the app on all the interfaces and see if that will work. So app tag A, let's see. All right, so app tag A is doing the app for all interfaces. Okay, so I think I see why we couldn't do it for the WLAN 0. Okay, I see why the app couldn't work for that particular WLAN 0, because it's not fully accessible. So when we do ifconfig WLAN 0, you say that we have the interface, even though it's associated with the access point, but it doesn't have an IP address. All right, so that's why we couldn't. So we have to let it get IP address from DHCP, so automatically assign an IP address from DHCP. So to do that, let's clear a screen, and then we'll use DH client, and then we'll just say DH client. That should do it, but we have to add this so that it will do the DH client in the background, okay, so that we can have access to our prompts. Okay, so yeah, we have access to our prompt back. So let's check again and see if our Wi-Fi, our WLAN interface now has an IP address. Okay, good. So you see that we now have an IP address. And then, so this is the subnet mask. So it means the network part is 192.168.1, and then this is the host part. All right, so we are on the 192.168.1 network. Okay, good, fantastic. So now if we come back to do our app, and then we specify the interface WLAN 0, we should be able to see other IPs on this particular network. All right, good. So you can see that it works now. So we have IP address, which is 192.168.1.1. This is probably the IP address of the gateway, that is the router. All right, so let's copy this as well. Okay, so this is our router's IP address. So what can we do with this IP address now that we have it? So the next step, or what we want to do, is to scan this particular IP address for open ports and services. Okay, so how do we do this? We can use nmap, but if we do which nmap, we can see that we don't have nmap on this box, so we have to download a static binary, nmap binary. So we can do that, nmap static binary GitHub. So we're gonna download the static binary of nmap from GitHub. Okay, so let's see which one we can use. Let's try to use this. You can try. Okay, like, yeah, we can try the first one or this one. Okay, let's go with this. So what we do is we can download this particular static binary. Is it downloading? I don't think so. Oh, okay, it downloaded already. All right, so we have it in our download folder. Oh, multiple downloads. No worries. So what we're gonna do is we go back here, let's clear, and then we copy it from our downloads folder, nmap onto our main machine. Okay, so we need to use sudo. Okay, all right, so we have the nmap. So this one is different from the nmap result. Let's see, let's check the file nmap. There should be a static binary here. So that's it. So it's an executable statically linked. All right, so this is the file that we are talking about. We can even try to see if it's actually the proper nmap binary. So we can do well, that is the correct binary, so I'm not going to waste time. I'll just copy it onto our remote machine and then use it to scan. So our server is already running, so we are hosting all the files in this particular directory, so this save directory. So we should be able to access our nmap. We should be able to copy it over here. So we'll use curl http 10.11.14.79 8000 and then nmap. So we save it as nmap. All right, good. So it's copying it onto our remote machine. If we do ls, we can see our nmap file is here, but it's not executable, so we make it executable. Okay, if we do ls, so our nmap file is now executable. So what we do is we just use it to scan our IP. So scan 192.168.1.1. all right, so it's scanning. So yeah, the scanning has been done, so we can see some ports open. So this is port 22, which is SSH, port 53 DNS, 80, and then 443, which is HTTPS, SSL version of HTTP. All right, so this is great. So what I'll do is I'll just copy this information. All right, I'll copy this information nowhere. Let's copy it here. Okay, great. So it's like ports in this particular IP is port 80 is open, so it's like there's something is hosting something on a web interface. All right, so we can try to access it with curl. So 192.168.1.1 is, if we just specify port 80 or we don't specify, it's going to go to port 80. So let's see if this will bring something. Yeah, so we can see some HTML information and then probably some scripts. Do we have scripts? No. Yeah, we have styles. Okay, so we have a page here. So it's like but it's only internal. All right, so what we have to do is to access this particular page from our system, we need to port forward. All right, so we will need to port forward. So we have how many IPs? How many ports? We have several ports, and then the ports of interest are port 22, and then this particular port, because this port is probably hosting a particular portal or something that will interest us. And then if we're able to port forward this port 22, we should be able to probably remote into that particular machine through SSH. So, but we can do port forwarding. We can port forward every single port, but that's not handy. So we can, in this case, we're trying to go by dynamic port forwarding. All right, so port forward every port. All right, so we can do that using proxy chains. All right, and then the tool we're going to use for the port forwarding is Chisel. Okay, so let's go and download Chisel. I have Chisel on my machine, so if you don't, you go to Chisel GitHub. Yeah, I think this should take you here. All right, so let's go to the releases and get a copy of Chisel. My system is a bit slow, very slow. All right, so yeah, okay, it's trying to load the assets. Let's wait a bit. Okay, so I'll be using this version. You can try any version that works with your system, but I'm going to use this version. Okay, so I'll copy Chisel onto my local machine. So let's clear screen, and then I'll wget Chisel. All right, so it's here. It's a gun zip. All right, so I'll use 7-zip to extract. So I'll use 7-zip to extract Chisel. All right, so it's been extracted. So when I do ls, I can see Chisel is here, and then I can change the mode. I can make it executable. All right, so if I do Chisel, all right, yeah, so it's working. Brilliant. So we are not done. We have to, because of the port forwarding we're going to do, we have to set up Chisel client and Chisel server. All right, so we have to send the Chisel to our remote machine to use it as a client. All right, so we go back to our remote machine, and then we kill 10.10.14.79 8000, and then Chisel, and the out file is going to call it Chisel. All right, so we're copying Chisel to our remote machine. Let's wait. Okay, so this is done. If we list, we can see that Chisel is here. So we need to do what we did on our local machine as well. So we make it executable. All right, so this is fine. So when we do try to run Chisel on our remote machine, yeah, it's working. All right, fantastic. So we have Chisel. So first of all, we need to set up Chisel clients, so our Chisel server on our local machine. So let's do that. So we say Chisel, and then server. So we're gonna do a reverse tunneling, and then the port we're gonna specify. Let's specify port 555. All right, and then yeah. Okay, so something has started here, the tunneling. So we come back here, and then we do Chisel, Chisel, and this is going to be client, and it's going to port forward to our local machine, which is 192, sorry, which is 10.10.14.79, I guess, and then we are listening on port 555. That's what we set up. All right, and then reverse port forwarding on socks. So we're gonna do it on socks. That's, we're gonna use proxy chains. Okay, all right, so it has set up some proxy chains here. All right, so we are not done. So proxy chains on this particular port 1080. So what we need to do, we have to modify our proxy chain config file. So how do I access that? Okay, let me just do it here. Okay, so let me do sudo sublime. I'm going to open the proxy chains file from sublime hc proxy. So proxychain.conf is a proxy chains for. Okay, you know. All right. Pass. Sorry about that. Okay, our password is wrong. All right, good. So we have it here. So go down. Okay, so this is SOX 4, but we want to use SOX 5. That's more current. So we say SOX 5, and then we put our configuration here. So it's 1080. All right. So this is fantastic. And then what do we do? All right. So we have the SOX configuration file properly modified, but we have to come and modify our proxy on the web browser. All right, so if you go to options, we can add a SOX proxy. So we add, so I'll just call this chains, because we are going to use proxy chains. We are doing proxy chains, and then SOX 5, and then the IP is 127.0.0.1, and then the port is 1080 if I remember. All right, that should be all. So we say save. Okay, so that is saved. All right, and then we have to select that particular chains, that particular profile. So we select the proxy chains profile. All right, and then if you try to access the remote IP, if everything went well, we should be able to access it if our proxy chains were set up properly. 192.168.1.1. all right, here we are. Excellent. So we'll be able to access it. But here, username, so we can try usernames or password. Let's try any password. I just slammed my keyboard, so the password was not properly set. You put anything in there, it will log you in. So you can even not put password, it will still log you in. All right, so what we do is you can look around, pop around to see what we can do, but the meat of the issue lies in the system administration pane. So when you come here, you can see the router password was not set, so you can set your router password here. You can also go to SSH keys. Let's see, SSH access, sorry. So it allows root logins. All right, so if you set up SSH properly, you can be able to access it by root login. Mostly on most machines, for security reasons, they don't allow root logins, but this one allows root login, so it's a plus for us. All right, but if you make a mistake and you deselect it, you'll be in trouble. So let's keep it selected. All right, and then we go to the SSH keys part. So it provides an opportunity for us to put in our public keys. So public keys allow for passwordless SSH logins. All right, so when you go to the SSH key access, SSH access, so Dropbear offers network shell access. So it provides a shell access into the router by SSH. So that's what it means. So because of that, if you put your public key here, you can use private key to log in. So public key authentication. All right, so since we know that, we have to we can create our own public key. So let's do that. I'm just gonna clear this. Let's move this one down a bit. So SSH, you can use SSH keygen, and then the file, I'll just call it Wi-Fi keys. All right, so no password. Let's clear and then list. So you can see that we have our keys here. So this is the public key and this is the private key. All right, so let's open the public key. Okay, so this is our public key. So this is the key that we are going to put into our portal. I think I pasted it twice, and then we can say add. So it has added our public key here. So we can now use our private key to SSH in. All right. So what we do now is, but we have to use proxy chains because we can access that particular port, the port 22. Where do we have it? So this port 22 is a local port. It's only sent internally. Yeah, but because we already port forwarded all the ports, we have to use proxy chains to access the port 22 if we want to SSH in. All right. So we say proxy chains SSH tag I. So the identity file we're going to use is the Wi-Fi keys. All right, and then we just say root at 192.168.1. Okay, so in this case, if we do it this way, it's not going to work. I should have just tried it. I know it's not going to work because the identity file, it has to have some special permissions. So we have to change the mode, mode 600, and then Wi-Fi keys. Okay, so the private key, you have to give it this permission, if not it's not gonna work. Then we can now go back to our proxy chains and then SSH I Wi-Fi keys, and then we can log in as root at 192.168.1.1. yeah, if everything is okay, we should have access to the access point. Okay, we say yes. Okay, great. So we've been able to get a shell into the access point. All right. So that's the box. All right. So we can clear. So let's see. Let's list, and then we can see our root flag here. So let's see the content of our root flag. Cat root.txt. Voila. So the machine is done. We're able to compromise it. We have our root flag. Okay, great. So we just submit this root flag and then the user flag. So let's go back to HackTheBox and do our submission. So our user flag, and then let's bring our root flag. So submit. Let's see if it's correct. My network is very slow. Very slow. I don't know why. And then we can submit the root flag as well. Let's not wait for one to finish. Let's see. Oh, what happened? I think network issue. Let's wait. Okay, so let's submit it again. I think I tried to submit it 2 at a go. Probably a race condition. This can be right. Okay, let's refresh. Let's refresh our, because I think our flags should be correct. It's always good to my network is a pain. So I'm having issue with my network. So what I'll do is I'll just pause and try to figure out my network issue. Okay, so I think I know why my network issue was having that problem, because I was going through the proxy chains. All right, so I'll just go to no proxy. I think this should resolve the issue. Yeah, my proxy was on, so it was intercepting all the traffic. Okay, come on, let's cancel and then refresh. Okay, so let's go here. Let's submit this. Okay, yeah, so that was correct. And then all right, now it's also correct. So thank you so much, and see you again in another